Namaskaram. Welcome to the course Basics of Electronics. In this video, we will be looking into analog to digital converters in electronic industry, which are also known as ADCs. This video tutorial is divided into 4 important parts. First one is what are ADCs and how does they work. Second part is types of ADCs and their significance. Third important part is applications of ADCs in electronic industry. Last but not the least, fourth one is advantages and disadvantages of ADCs in electronic industry. So let's begin. What is ADC and how does it work? ADC, which is nothing but an analog to digital converter in electronic industry, is an electronic integrated circuit, which is very essential and very commonly used one part of the circuit in entire embedded system. This circuit is responsible for converting analogous values into a digital sequence of bits, which is easy for understanding, processing, controlling, and also storing inside the memory devices like microcontroller or microprocessors. Let us consider 2 examples to understand how does these ADCs works in real world. First example is this microphone. Now I am speaking in front of this camcorder, and the voice that I am generating is now converted into a digital bit by using this microphone and analog to digital converter inside this camcorder. It is responsible for converting this analogous variable voltage into a digital sequence of bits like ones and zeros that is easy for understanding for the computing devices inside the camcorder. In another example, which is the second example for this understanding, is a temperature logger. We all know that temperature is a physical quantity. This particular quantity is converted into analogous voltage by means of temperature sensors. These analogous voltage are given to analog to digital converters so that this particular analogous value is converted into a digital sequence of bits or a digital data which is easy for understanding for the controlling devices, memory devices, or the computing devices, which is essential for further action. This is how analog to digital converters works in real time. Types of ADCs and their significance in electronic industry. Analog to digital converter circuits are very complex and very sensitive device engineering in the entire SDM industry. That's why it is very specific to analog device design engineers in the entire industry of electronics. There are multiple technologies in the entire industry with respect to design and development of ADCs inside the hardware. However, we are here with the 5 important technologies very common to entire electronic industry. First one is successive approximation type ADC. This is a balanced resolution and accuracy based ADC which uses the sample and hold circuit inside. This is a very classic example of the entire analog to digital converters inside the electronic microcontroller industry or the microprocessor industry. This successive approximation type ADC works with the multiple channels multiplexed with a single hardware, which enables to connecting a multiple analog sensors with a single hardware and multiplexing them as in when needed. That's why it is very commonly used in most of the microcontrollers and microprocessor nowadays used for DIY segment as well as for low-level ADC industry. Second one is Delta Sigma ADC. This is one of the rare kind of ADC inside the industry because it uses the DSP technology, which is digital signal processing. Hence, it is very suitable for audio engineering or audio signal processing. Third one is dual slope ADC. As name indicates, it uses the dual slope formulas to convert the analog value into a digital signal, which is again integration method in the entire process of conversion. Since it uses the integration method, it is not as fast as flash ADCs, but very good at accuracy and resolution as compared to the SAR and Delta Sigma ADCs. Fourth one is pipelined ADC. As name indicates, it pipelines its execution of conversion from one stages to another stages. It is relatively faster than the SAR ADC or Delta Sigma ADC, but not as fast as flash ADCs. In this particular ADC, sample rate is inversely proportional to the bit resolution. As you increase the sample rate, you have to decrease the bit resolution. Fifth one is flash ADC. As name indicates, it is the fastest ADC in the entire electronic industry with respect to analog design engineering. Flash ADC circuit is very complex and power hungry, and the bit resolution is limited to 8 bits at a time. Even though if you are looking for multiple bits, you have to increase the circuit and you have to create a multiplexing threads with respect to the hardware, but it is not possible to go beyond the 8 bits with one ADC IC with respect to flash technology. So these are the 5 different technologies in ADC in electronic industry. For more detail about these things, you can explore on the internet. Now it is time to talk about the applications of ADC in electronic industry. There are limitless applications with respect to electronic industry for ADC circuit being used inside them. However, you can find that ADCs are used in every electronic gadgets now in electronic industry, because mobile phones, smartwatch or Bluetooth earphones are having analogous data capturing sensors which requires ADC for conversion. Here are the 4 examples for understanding how ADCs are used in electronic industry. First one is current and voltage measurement in IoT devices. When you consider IoT devices, they must be portable and operated with a battery. When we say it is portable and battery operated, we need to take care of what is the power left in the battery, when we need to charge them, and how we can optimize the power consumption of the entire device. For that reason, you have to measure how much current is consumed by each and every peripheral. Also, you have to measure what is the voltage of the battery. Based on that, you can take action. That's why measuring the voltage and current in electronic industry, especially for IoT device, is very essential. On that time, ADC comes into the picture to convert that analogous voltage into a digital sequence of bits or a digital data which is easy for processing, controlling, comparing with respect to microcontroller inside. That's why ADCs are used in IoT devices. Second example is analog sensor interfacing with microcontrollers. Consider an example of a temperature thermometer or maybe a temperature logger. That temperature sensor is an analog sensor because it generates analogous data based on the temperature around it. So when we consider those kind of sensors, we need to interface those particular sensor with a microcontrollers or microprocessor for further processing or controlling. On that time, conversion of that analogous voltage into a digital data is done by ADCs. That's why ADCs are widely used or integrated part of every microcontroller nowadays available in the industry. Third one is power monitoring in electronic industry. The power monitoring industry or the power electronic industry as a whole in ESDM industry is one of the big advantage of this particular electronics, where we monitor the power consumption, power factor, various frequencies and various parameters with respect to power electronics or huge equipments. On that time, converting those analogous voltage value into a digital data which is easy for your computer to understand or your electronic gadgets to understand, the ADC plays a vital role over there, because ADC does that conversion and without which it is just not possible. Last but not the least, fourth one is analog communication system. When you talk about the communication, there are various digital communication in the entire industry for long distance or wireless communication. But in short distance and very specific need where analogous data need to be sent over the air or maybe over the internet, on that time, analog communication systems requires analog to digital converters and digital to analog converters for the transmission and reception of the analogous signal. That's why ADCs are very widely used in entire electronic industry, no matter what is the scale. Let's talk about the advantages and disadvantages of analog to digital converters. Of course, in any technology, there will be a pros and cons in the entire system. So that's why let's talk about the advantages first. First advantage is it is easy for the design engineer to develop a system around the analog sensors. Because of availability of ready-made ICs of ADCs, or they are being a part of our microcontrollers or a microprocessor, it is easy for the design engineer to interface any analog sensors with the embedded system or create embedded system by using analog sensors in the system. Second advantage is high accuracy and reliability in electronics. When it comes to discrete electronic circuit which performs ADC function is not as accurate as an integrated circuit designed by machines. That's why ADC ICs makes our job very easy with a high accuracy and reliability. When it compared with the inbuilt ADCs inside a microcontroller, it becomes even more easy for the designer to trust on the data that is coming from the ADC. Third advantage is fast conversion rate with respect to analogous data. If you compare with any kind of a flash type ADCs or maybe a successive approximation type ADCs, they convert analogous data into a digital data as fast as possible with respect to bit resolution, which makes it easy for the developer to use them for a fast and quick response system design engineering. Fourth advantage is low cost solution for the DIY segment of electronic industry. Because developers are doing a DIY project or a small scale project or low budget project, on that time ADC ICs plays a vital role by being very easily available, also for cost effective solution. That's why ADCs are very commonly used and being integrated part of most of the microcontrollers nowadays. Now let's talk about the couple of disadvantages to understand the limitations of ADC IC in electronic industry. First one is requires a filter design to avoid the noise in the system. These ADCs are very sensitive to the noise that is available around the system. In case of any inductor nearby, it will catches that electromagnetic flux as an input by means of any channel or any connecting wire flying through that particular area. That's why ADC requires a very good designing, which is also known as analog design engineering, for the specific understanding or a specific requirement. Second disadvantage or limitation is accuracy of the ADC circuit or ADC system is highly dependent on the external component being used along with the integrated circuit. If you use a very low quality material or high tolerance material, then obviously the accuracy is not going to be as accurate as you are expecting with respect to integrated circuits. Third disadvantage is requires a stable source voltage for these ADCs to perform a calibrated level. Say for example, if you are using a 5V ADC IC, then if your input voltage itself drift from 4.8V or a 5.2V, then your calibration curve doesn't fit. On that time, output also differ as per the expectation. That's why stable input voltage is a condition for the ADC to work. Fourth limitation or a disadvantage is these ADC ICs are vulnerable with respect to temperature around them. If the temperature around them increases or decreases above and below the bracket of recommended temperature condition of the IC, then obviously they will create a drift inside the IC, which will vary the output voltage even though you have done a calibration curve with respect to the IC. That's why these particular ADCs are used in a certain condition where the temperature is under control, also where it is a predictable drift with respect to the temperature. So these are the couple of advantages and disadvantages of analog to digital converters inside electronic industry. I hope you enjoyed the entire detailed tutorial about the analog to digital converters in electronic industry. See you again in the next tutorial. Until then, happy learning. Namaskaram.